Hello, this is Nick Lightbody from Desk-Based Systems in the UK. A few years ago, back in 2015, it occurred to me that it was possible to test FileMaker Server by using server-side scripts. That's because, as you may recall, each server-side script is an independent user session, and if when you run a server-side script you don't choose to pause the calling program until that script has concluded, it means that with a looping script you can make any number of those server-side scripts that then run as autonomous individual sessions, and hence you can create a load on FileMaker Server. And that's exactly what we're going to show you today. dsBenchmark came out of that research project. We spent several months working out how to do this, testing various ways of creating the load and the data we wanted to use to test with. So here's dsBenchmark. It is a public domain offering in the sense that we've given it to the community. It's got full access to it so that you can learn how it does everything, and it actually fulfills two functions. One is it is this load testing app for FileMaker Server, but it also offers a library of high performance techniques that you may find useful. So let's fire it up and see what happens. Because we're in the UK and we are looking at this on the US West Coast, it means we've got a little bit of latency to deal with there. The first thing to note is it comes ready configured in several different languages. So if we click, we can see. So here we have the Russian version from Mark Killen of CE Labs, the Swedish version by Johan Hedman, the Chinese version by David Zhang, the Spanish version by Ibrahim Bitter. I did the original English version, and we've also got French by Pauline Lafitte. So you can choose what language you want here, and it'll then, basically everything is in that language throughout the entire app, but we'll stick with English so we don't get disorientated. Click OK, and it fires up. Now it's automatically set up to do testing, so the first thing it does is tells you what the full access password is if you want to do that, and takes you into the testing part of the app ready to run a test. So here's the full access. Secure username, secure user password is what you require, and it asks you to describe the server. So let's say this is FileMaker Server 17 on EC2 T3 medium, I think it is. Now that event comment is attached to every event record, and the way that this works, we just ask us if we want to delete the existing records, which the answer is delete. The way that this works is the virtual users will just create records, and for every record they create, they'll create an event, and each of those events will record all the relevant data from the system at that point. So if you want to do analysis, you can look at the FileMaker file of data that's exported from this when it finishes, and you can do whatever sort of analysis you want. And because every record has got all the data regarding the test circumstances and the environment at the point at which the record was created, you can of course take the records from a whole series of testing, consolidate them in a whole into a whole set of data, and analyze it in different ways. So it's also designed as a mobile first app. part of what we do, is everything we've been doing since about 2014 or 15 is mobile first. So it of course will be as big as we want it to be, and all we're going to do here is go test. Now we have inactive users, busy and intense, and we can run any number of each of those, but just for a simple test as a demonstration I'll just do the intense version, which is the fastest. It's the one where the server is being hit intensely by people making records on a fairly rapid basis. So let's just click on there, and how many users? Just put in 500, which is the maximum that you can have under FileMaker Server. 500 server-side scripts is the maximum you're permitted. And let's, for the sake of argument, put in 1 token. We can put as many tokens in as we want, and the tokens are a method of load balancing. Essentially, by putting in tokens, it gives the app somewhere to park calls that are being received at a point at which the performance is declining, and it parks the calls into a loop, and it then waits until the performance has improved a bit before releasing those calls. And it's got up to 6 of those tokens it can use, so 6 of those loops it can use, and that's just one method of showing how you can improve the performance of your FileMaker app. But let's leave it on 1 token as a basic testing scenario, and away we go. Now, the point to remember about this is that, and the clue's in the name, it is called dsBenchmark for a reason. It isn't in fact trying to simulate a real user situation, because real user situations are very variable, and hence trying to simulate them is not, in our view, particularly useful. We believe that the most useful thing you can do when testing FileMaker Server is to compare one deployment with another. So, for example, supposing you're being offered 2 different Amazon deployments. Maybe you want to use 2 different server specs, and you want to see how one compares to another under load. Or perhaps you want to compare 2 physical FileMaker Server deployments on real boxes, or maybe you want to compare physical with virtual, or whatever it is. The point is that if you run the same test using dsBenchmark on different deployments, you can then compare those deployments on an absolute basis. Because when you're dealing with either your own systems or clients, whoever is the user or the users, the system administrator of the system, will know what works and what doesn't work. They'll know that such and such a deployment is happily going to accommodate 20 people or 25 people or something like that. But they also know that if they have 50 hitting it, it really isn't going to quite hack it. So they'll have their own experience of what actually works. So if you then run dsBenchmark on that deployment, take the data, which essentially is the maximum number of users before it ceases to be performant, from that particular deployment, you get a baseline, a benchmark. You can then run the same test on a variety of other proposed deployments and judge how much better or worse those deployments would be than the one that you've used as your original benchmark. So if, for example, your client knows that their 25 users are happy on a particular server, but if they go above it, it isn't so happy, and if you find another form of deployment which appears to happily take twice the load that their existing server does using dsBenchmark, you then have a pretty fair idea of what performance your client or the users are going to get if their existing system, their existing FileMaker system, is moved over to the new deployment that you've been testing. So that's the idea. We do appreciate, obviously, that various people try and test in various ways, and to be honest, when we started this research project, we did the same thing ourselves, but we then realized that if we put in a random delay in each user action, it actually made it impossible to compare one set of data with another. So that's why we've done it this way. And while this is running, you can see if we click up here, we can actually start another test. When the number we set to be created has completed, we can start running some more tests simultaneously. So if, for example, instead of setting it for 500 intents, I'd set it for, say, 25 intents. When the 25 have been started and that particular script has concluded, I could then set it to do 25 busy. And then I could try, and when that's concluded, I could do 25 relatively inactive. The point is I can actually create a mixture of different types of users in one of these tests if I so wish. Right, we've got a result. So you can see here that the main line, the blue line, which is the user number, started at 0, and having accelerated, or having started very quickly at the beginning, it slows down after about 10 or 12 users, and then the user numbers increase on virtually a straight line until this point here. Now that's probably where we did something else on this machine while waiting for this to complete. The normal expectation is you get a pretty straight line on EC2 until you get to the point at which the thing ceases to be performant. Now we define performant as being the normal or average response time for users exceeding 3 seconds. So you can see 10 seconds is here. So you can see that round about here, this is where you start getting some peaks of over 3 seconds. So if you look at that there, this is pretty much where the initial increase in user numbers starts slowing down slightly, and then it gets a little bit more intermittent until it peaks out at 110 users in this case. And the reason that this stops is because dsBenchmark automatically stops. Although we're testing this with autonomous virtual users, i.e. autonomous server-side scripts, each of those scripts within its cycle of creating new records checks back to values in a non-global single record table, which hence is something that these separate sessions can all access, where of course they couldn't access something that was global. And that's where we set the stop marker when the thing ceases to be performant. So we actually tell it to stop when the normal response time starts exceeding 6 seconds. And if you look at what happens here, you can see that it builds up slightly. The red line, which is the dequeuing, which is using the token, starts at this point here. You see there's nothing until here, and then it starts coming in pretty rapidly now as the whole performance starts falling as the thing becomes choked. And at this point the stop is set, and then all of those server-side sessions get automatically closed down, and the thing is then ready for you to go back to and continue with. The point here is that we have a period that when the thing is stopping, sometimes the very last period is very, very long indeed. But the important thing about this test on Amazon, of course, is that it does stop very cleanly. When you see this sort of test on a on a normal non-virtual server, very often they take quite a long time to close down because the FileMaker Server gets so choked. Its ability to close down the virtual scripts is becoming very limited. So that's what we get there. Now when I click Done, it's going to do a couple of things for me. First of all, it's going to export a PDF graph. We'll use A4, but you can use whichever size you wish. So we'll say that's exported there. It also exports a data set to the desktop, so you can then check that and examine it. Now while we're here, let's take a quick look at what else there is here. If I go to the menu, and if I go upper level to the top menu, okay, so we've got About, Your Data, Preferences, Manage, DevCon 2016 Examples, and Logout. So if we go into About, here is our performance screen. Here is the events table. So you can see here that there are 972 records that have been created. If we look at any one of those records, you can see the data that's actually held for each of those records. So you can see it's got the Amazon server name, where it is, blah blah blah, all relevant information, what version it is, machine ID, and all the other things that you might want to know about. If we now go back up a level, we've got Help, About. The Performance Dashboard gives us a way of analysing the results. So you remember you've got about 900 odd records here. If I click on All, okay, so they are, there's 100%, which is 974. We can then say, okay, how many of those records were completed in 1 second? So, and this is actually average, so in fact this is up to 1.5 seconds. The 2-second band is 1.5 to 2.5, etc. So you can see here that 86% of those records were created or completed in an average of 0.14 of a second, minimum of 0.02, and a maximum just under 1.5. And then how many were completed in 2 seconds, etc., etc. And this actually uses FM SQL as the method of doing that checking. So again, if you're interested in using that form of data analysis, then there's an example there. And you can see these records are coloured, and the coloured backgrounds are added when the performance starts decaying. You can see here that the records in the 2-second one, there aren't very many of them. So it's really quite, I'm very impressed by the performance on this EC2 deployment, because most of it worked extremely fast. Very well done, Amazon. Very well done actually to the guys that developed the Linux version of FileMaker Server to run on the Amazon cloud.